Chapter 22, Example 1. Curious about sleeping habits of college students, Jane decided to survey a random sample of 25 students at a local college, asking them how much sleep they had on the previous night. Let's build a 90% confidence interval for the mean amount that college students sleep in a night. What can we say about the mean amount of sleep that college students get? So we're doing a confidence interval here. Check our conditions. The sample was randomly selected, and 25 students are fewer than 10% of all students at the college. So now the next thing we need to check nearly normal, so let's look at that. I have the plot there, a histogram. It's unimodal, maybe skewed a little, but no outliers, so we're okay to go with this. It's not going to have to be perfect. The histogram of hours of sleep is unimodal and slightly skewed, but not enough to be an issue. The conditions are met. I will use a student's t-model for a one-sample t-interval with 24 degrees of freedom. So in order to do this, we need some statistics for it. We have the data that I'll provide for you. We're going to put that in a table and then get our standard deviation, our mean, and all that stuff. So think back to like the first 5 chapters, really. We're going way back. We've got to get those 5 number summaries. We don't really care about the Q1, Q3, all that stuff for this problem, but the 5 number summaries does give us the standard deviation and everything. So do a calculator page once you've got all the data in. We're going to go to Statistics, Stat Calculations, One Variable Statistics, because we're just dealing with one here. Pick the list that we had. Make sure you name that column. We named it Sleep. Hit OK, and there's all our data. Now, we see the standard deviation up there barely, but we need to scroll up to see the mean. The mean, X bar, is 6.64, and our standard deviation is the S, the N minus 1, because we're doing it with minus 1 degrees of freedom. So we use that 1.075. So now we want to put those statistics down. So that's all referenced there in the problem. N equals 25. X bar is 6.64. The standard deviation of X bar here is 1.075. So our standard error we calculate from the formula of X bar will be 1.075 divided by the square root of n, our sample size. So the square root of 25. And this comes out to be 0.215. To find our t-score, we know we have a sample size of 25, so our degrees of freedom is 25 minus 1, 24. We're going to go to our t-table, and we go down to 24 degrees of freedom, and we go across that whole row. That's what we're looking at. Now we have a 90% confidence interval, and of course, t-model is two-tailed, So we're not looking at 0.1 up at the top, we're looking at 0.05. We have to take half that value. We want 0.05 on the left side and 0.05 on the right side. So I look at that 0.05 column and I come down to where it meets at 24 degrees of freedom, and right there we get 1.711. T with 24 degrees of freedom will equal 1.711. And we get that from the T table for a 90% confidence interval. The margin of error will be 1.711 times our standard error, which was 0.215. And this comes out to be 0.368. So our margin of error is 0.368 hours. Our 90% confidence interval will be 6.64 plus or minus that 0.368. I am 90% confident that the true mean number of hours that college students sleep is between 6.272 and 7.008 hours.